Hey, this is Mr. Coker with another geometry lesson. And this lesson that I'm going to go through today is one I don't have a video about yet. And again, this is a geometry preview for my Algebra 1 class. And this is about central angles. Now, when I'm teaching this, I'll go through this again in geometry class a little bit more than I am here. I'm going to try to give you kind of the basics of finding central angles. So, the central angle, what we're talking about with this is we've got a circle. So, we've got a couple of circles drawn out here. And if you look at it, it looks like a bit of a mess. We have a bunch of lines. We have each point at the end of each line, where it intersects with the outside of the circle, is labeled here B, C, D. Oh, that's supposed to be A, E. Oops, an E and an F, and then we have numbers. First thing I want to point out, very first thing that's extremely important here: how many degrees are in a circle? That's the first thing you should know. In a circle, we have a total of 360 degrees. That's the first most important thing to know. Second most important thing: how many degrees are in a semicircle, meaning half of a circle? What's half of 360? Well, it's 180. I'm writing that number down too. So 360 degrees in a full circle, and 180 degrees. That's ugly, but it's it's a half circle, half of a circle. I'm not rewriting that. I want to, but I'm not going to. Okay, so the third thing to know is this inside where two lines intersect, of course, is an angle. And an angle, this is an angle sign I'm going to draw to right angle. If you see this symbol, that's an angle. And if you see this symbol, which you might notice here and here, that is an arc. Okay, I cannot help myself. I've got to redraw that because it's so ugly. I was like, I'm not going to redraw it. I'm not going to redraw it, but it's still ugly. Whatever. Okay, so if we have an angle is the error is, like say this 55. It's where two lines intersect. We've been through angles in previous videos and assignments. An arc is a part of the outside of a circle, part of the circumference. Look at the symbol for arc. It looks like part of the outside of a circle. This 70 is an arc. 55 degrees is an angle, 70 degrees is an arc. When we're talking about central angles, the last prerequisite I want to get to, the arc measurement, the measurement of the arc is equal to the measurement of the corresponding angle. So what this means, angle DE is 55 degrees. Arc DE is also 55 degrees. If arc EF is 70 degrees, then angle EF is also 70 degrees. Oh, one more prerequisite, I'll get you that in the second one. So this asks us to find the arc FB. Let me find the right color to choose. Arc FB. This is what we're finding, and I often I've suggested to students in the past who are having trouble visualizing. Do just draw or shade in, maybe. You could like shade in like this. Or draw a little line to show what you're trying to find if you're having trouble kind of visualizing it. Okay? We want to know what this is. Now, granted, you look at this, you could think, well, how would we know what this is going to be? We don't have any information. Now, when we're doing this, we want to assume that any, and your assignments should tell you this, to assume that any lines that look like diameters are diameters. And what that means is, if we see a line that looks like a straight line that goes from one side to the other, we're assuming that is what it appears. So this line goes straight through the middle and to the other side. That's what's called a diameter. This is a diameter. Those split the circles into halves. Something important here. That 55 is unnecessary. It doesn't tell, we don't even need the 55. Here's why. If we go from B all the way around to E, if we go all the way around from this point to this point, that's half of a circle because we have a diameter that splits the circle in half. We could ignore this half of the circle, and all we have left is this. Well, what degree? How many degrees are in half of a circle? 180. Well, what do we know on this side? We know that this section, not the section we're solving for, but the other part, is 70 degrees. Okay? From E to F is 70 degrees. Remember, we're ignoring everything on this, everything I'm covering up. We're only looking at this half of the circle. We know that there's 180 degrees total. We know that this portion is 70, and we know this portion, well, we don't know it. That's what we're searching for. 70 plus x equals 180. Now we solve it. It's a one-step equation. Minus 70 on both sides, and you get 110. So x equals 110. Hopefully all that is showing up on my video. I'll see that in a minute here. A few minutes when I watch it back. But anyway, x equals 110. That's our answer, 110. 110 degrees. So I'm going to say this FB is 110. And notice I put x equals because it's easier. Now, I'm going to move on to a harder problem. Well, it looks harder. It's not too hard. Okay. The second one I have here asks, now notice here we have a lot more information given to us. We do not have a diameter on this one. My drawing here kind of looks like a diameter. It's not meant to. Okay, let me actually fix that. Make sure it's clear. It's no diameter. About it is not anything near 35. Oh, why not put 35 on the inside? Maybe put it on the outside. Whatever. Anyway, I redrew it just so it's clear that's not supposed to be a diameter. Okay. Here's what they want us to find now. BCE. I said the one more prerequisite. This is what it is. When you find FB, you just go from F to B. You know not to go all the way around. It just tells you FB. So go from F to B in the shortest possible way. But what if it says BCE? Well, notice that B and E are on opposite sides, right? I mean, there's something in between them. Well, if we just wrote BE, you wouldn't know which way to go. You wouldn't know, are you going this way or are you going this way? The BCE tells you to go from B to E and include C in it. Very practical. So, let me get the good old brown one again. And I'm going to color in what we want defined. To be clear, when I put X equals this time, that will not be the answer. So here's something very, very important. We need to know what's the area from B all the way around to E. Well, we see a 50. Now remember, this is finding the arc, it's not the angle. But the arc and the angle are the same. So 50, this is 75. And the reason this is 75, if the central angle corresponds to its arc, or it's equal to its corresponding arc. So we know we have a 50 and a 75. But what we don't know is this part. So we're going to do 50 plus 75 plus something to give us our answer. But since we don't know what it equals, we can't just set up an equation yet. What we've got to know, we've got to fill this information in. Now, fortunately, they give us the measurement of every other segment of the entire circle. How many degrees are in the entire circle? 360. So I'm going to do 75 plus 50. 75 plus 50 plus 75 plus 35 plus X, X is DE, equals 360. Hopefully this doesn't look too difficult, but if it does, well, hopefully it doesn't. What we'll look at here is that we've got, we're going to combine our like terms, 75, 50, 75, 35. We're going to combine all of these. And what we're going to wind up with is what? 235? 235. 235 plus X equals 360. Now, in your calculator, you can do 75 plus 50 plus 75 plus 35. Get 235. Plus X. Now it's a one-step equation. X equals, hopefully this all shows up on your screen, 125. X equals 125. I didn't box it in. That's not your answer. Not yet. To get that final answer now, remember, we want to know from B all the way to E. So now we know 125 goes here. But that's not the final answer. The final answer is going to be 50 plus 75 plus 125. Add those together, we get 250. A little degree sign for good measure, and that's it. Personally, I love these types of problems because it's like a puzzle. It's like filling in. You're filling in information. If you're looking for what information do you have, what information do you not have. I like them. A lot of times students don't. I've noticed that, but hey, that's okay. One like this is pretty straight. Hopefully, is pretty straightforward. But it takes knowing the 180 to make it a lot easier. This one looks harder. It's not hard, it's just more time consuming. If you can fill in every piece of information on your circle, you're going to be able to solve the problem without much issue. It could be time consuming, but it shouldn't be. Hopefully, it's not hard for you. But hey, if it is, just it takes practice. Last thing I want to say about this is, notice how it says find BCE. It wants to know that whole arc. Well, I want to make something clear. I'll start on this one. FB, remember, if we were finding angle FB instead of arc FB, same answer. It would be the exact same answer in the same process. Because if this arc is 110, then this angle is 110. You get it the same way. And same idea. If we were finding angle BCE, or you call it BDE, it wouldn't really matter. But if we're finding the measurement of this angle where B and E intersect, it would also be the same thing, 250. Because the central angle is always equal to the corresponding arc. So I point that out because sometimes you'll be asked to find an angle instead of an arc. I took these off of the assignment that I'm putting up. So that's why they both randomly have, I took the first two problems off of it, so that's why they randomly have, both have arcs, but oftentimes they will ask you for angles. So anyway, I hope that makes sense. I hope you all, thanks for watching. I hope you all have a good rest of your day, and that your digital learning is going well. Have a good Hey, and I see now it all got on screen. So when